Hi, my name is Taylor Buster, and this is my presentation on a description of gravity as a wave celerity differential for my physics capstone project. Now, the base concept is that instead of gravity causing time dilation near massive objects, the effect is reversed. Time dilation causes an effect similar to gravity, or that we observe as gravity. This is due to the fact that further from massive objects, time moves faster. This difference in time velocity creates a kind of pressure differential that results in the phenomenon we observe as gravity. Now, this idea has been explored most notably in two other papers that I found, one by Manuel Arminjon in his Scalar Theory of Gravity as a Pressure Force, where he more specifically observes the idea of a kind of ether pressure perpetuating the force that we observe as gravity. The biggest difference between what I'm suggesting and what Arminjon suggests is this ether that he talks about. And in his own paper, he discusses that he does not believe further credence should be given to the idea of ether, but in that describing gravity as a kind of ether pressure, it might give us some unique insights and unique approaches to how we view gravity. More similarly is Joseph H. Forrington's Time Dilation Cosmology paper, in which he actually describes gravity in the same way. However, his process for doing this is by using the Schwarzschild metric, which is a specific solution of Einstein's field equations, most notably used to find the event horizon of a black hole based on the mass, but does relate time dilation to mass and therefore gravity. He uses this equation to describe all gravitational phenomena by the time dilation. My biggest issue with his paper and his process is that his method is much more similar to choosing to describe velocity as the seconds it takes to travel a meter instead of the meters traveled in a second. They're both effectively the same description, and in fact there is no real reason to give one preference over the other. That is the purpose of this paper. In order for us to prefer the method of describing time dilation as causing gravity, there has to be another cause for time dilation, and that cause is what this paper in this presentation will further explore. Now, to begin, we start with the equation of motion for fundamental particles, specifically as provided by Matt Strassler, but what is used in quantum field theory. Specifically, this equation right here describes the wave function of a fundamental particle, its frequency right here, and its wave number over here, which is a result of its interaction with the Higgs field. The Higgs field in quantum field theory is the only thing that gives particles mass, and that is this function right here. Now, specifically what we want to take from this is V delta, which is the deflection from nominal wave celerity. Nominal wave celerity being the speed of light right here. In this equation, you can see that if mass is 0 over here, the phase velocity, which is calculated by taking frequency divided by the wave number, is c, is the speed of light. So massless particles such as light travel at the speed of light, or have a phase velocity and group velocity that is equal to the speed of light. Any mass over here increases the wave number over here, since they are both negative, and therefore also increases the phase velocity. So as phase velocity increases, this V delta also increases. Now, substituting this in, along with a description of mass in this here is defined as h naught y, where h naught is the vacuum energy of the Higgs field, and y is the strength of a fundamental particle's interaction with the Higgs field. These can be substituted in for my squared, as this whole thing, y squared h naught squared equals my squared. And all the other interactions that a particle has also contribute to its effective mass. That is summarized by this summation right here, all of which together is equal to m1, which is used in this presentation. Substituting these in and simplifying results in this equation. You can find much more details about that in my paper, which I plan to link in the description of this video and also submit alongside this presentation. But substituting in and simplifying down, you get E equals the reduced place constant times V delta times the wave number equals m1c squared, or E equals mc squared, one of Einstein's most famous equations. Now, let's talk about apparent wave celerity, because that is one of the most important things to address in this paper. Here we have water, this line and this blue grid, Here viewed from the side, here viewed from on top. Here we have a boat traveling. Now in both images, the boat appears to be traveling at the same speed because there are no waves. There is no vertical change to it. However, when we introduce waves, especially moving waves, all of a sudden the boat's velocity is partially downward as well, which is not visible from a top-down angle. So its effective apparent wave celerity or apparent forward velocity is given by this little arrow right here. From a bird's eye view, it appears to be moving forward much slower, even though it is actually traveling at the same velocity. In addition to that, the actual motion of the waves further reduces the apparent movement of the boat so that it actually appears to be traveling by this tiny little arrow right here instead of its true velocity right here. That is the difference between apparent wave celerity, this tiny little arrow right here, versus its true or nominal wave celerity, which is the larger arrow following the boat. Now, Newtonian gravity, one important thing to consider is that in order for these waves to exist, these fundamental particles wave to exist, they either require a constant influx of energy from their environment or a perfectly elastic interaction with its environment. I will be regarding the latter in this instead of the former because I find it much more reasonable to think. So in a perfectly elastic interaction, the particle interacts with its environment, its field, and the field also interacts with the particle. Both of them affect each other according to Newton's third law, so you cannot neglect the effect of the particle on its surrounding field. Now, to describe that, we look at the apparent wave celerity, how much that particle distorts that field, how big those waves are. And here we could describe the apparent wave celerity as the nominal wave celerity, the speed of light, subtracted by the height of the waves, which is the particle's mass, the phase velocity. This ultimately results, the slow restoration of this results in an energy gradient using B2 to correct the units. B1 here corrects the units of mass to velocity without turning this entire side into a constant. And the derivative of the energy gradient gives us a description of Newtonian gravity. With B2 and B1 being able to be simplified into this G over C squared that you see on this side of the equation over here. Now, to derive Einstein's equations from Newtonian gravity, I will be using a process better explained in greater detail by Chris. His videos will be listed in the references at the end. He does a phenomenal job of it, but the videos are 80 minutes long, and so I will be shortly summarizing them here. Now, the biggest change from the previous one is that you may notice that when I addressed the apparent wave celerity, I only included mass. I did not also include the group velocity, or which is the motion of the waves. That needs to be added in order to change Newtonian gravity into Einstein's gravity. We start with a curvature description of Newtonian gravity. Instead of what we did previously, which described the direct effect of one particle on another particle, we instead describe the effect that a particle has on its own field by giving this vector field, G, which is the acceleration due to gravity. You take the gradient of that equal to this right here, with this being equal to mass density, and this over here being the gravitational potential energy, just as described right here in the energy gradient, only as a curvature instead of a direct effect. Now, this is not entirely correct because we do not include velocity. So in order to correct that, this mass density needs to be upgraded to the stress energy tensor right here. The mass density is still present in the stress energy tensor as the top leftmost term in the 4x4 matrix that is the stress energy tensor. The other three terms of which is the spatial velocity in the three different dimensions. Now, whenever you do that, you also upgrade time from just regular t to c squared. And so because of that and several other factors, these constants over here need to be updated to this. Again, this is done in much more effectively and in better detail by Chris's videos. You will also need to update this over here to describe the curvature in several dimensions by using the Ricci tensor, which describes the three-dimensional density, more or less, how the field's density changes in space. And then in order to correct this a little bit, because this side over here is divergent with just the Ricci tensor, but this over here, the stress energy tensor, is non-divergent, you have to remove that divergence by using this term right here, which is the Ricci scalar times the metric tensor being the tensor that describes a straight path through a space. And this right here is Einstein's field equation in the most fundamental sense. So in conclusion, mass and gravity must be fundamentally connected. That was Newton's most brilliant idea with his law of universal of gravitation. It was not that it described the motion of planets. Kepler did that much more effectively 60 years earlier. It was that he said that mass and gravity are fundamentally linked. This has been so reiterated and reaffirmed, especially with Einstein's general relativity, that no further thought is really given to it. That is what this paper examines. The fundamental description of mass provided at the very start of this must also be the fundamental description of gravity. We achieve that description in this paper through the deflection from nominal wave celerity, this right here, how much a particle's mass and its velocity distort its true and apparent wave celerity with those waves and its motion compared to those waves. Now, what is most significant about this presentation and the paper that I will be linking is not that it introduces a new and deeper theory, but that it doesn't. It is the suggestion of this presentation and this paper that general relativity, as described by Einstein, can be derived from quantum field theory's equation of motion of fundamental particles. It does not suggest any correction to either equation, but instead suggests a recontextualization of gravity is all that is necessary in order to link these two equations together. With the derivations provided here, or summarized here and provided more clearly in this paper, there is no need for more complicated theories or undiscovered particles such as the graviton. Gravity can instead be understood simply as a pressure differential intrinsically linked to time dilation and quantum wave celerity. Here are my references. Once again, if you would like to see any of this in any more detail with more specifics, please check out my paper in the description or that I'm submitting alongside this presentation, or look at any of these references if you would like to see more detail on where some of these explanations come from. Thank you.